days like these make me lazy. So yeah, it's been a struggle getting through the day so far, but we'll push through it. This is the second lesson of Unit 3. Okay, so after Unit 3, I think there's one more lesson. We're going to do the final lesson tomorrow. I'm going to give you time to work on the Unit 3 review and some extra practice, and then we'll start Unit 4. So Unit 3 and Unit 4, I think, will get done by the end of the week, given that I am seeing you guys, well, cohort A I'm seeing twice this week, and cohort B I'm just seeing once. So that's 3 2-hour sessions, which is basically the equivalent of a week and a bit. Okay. So we're just going to get started. Today we're going to be solving linear inequalities. So just a brief explanation of what these are. So some definitions we need to refresh ourselves with is that an inequality is two expressions related by an inequality symbol, such as less than, greater than, less than or equal to, greater than or equal to, and cannot equal. So just a simple example we have is 5x minus 2 greater than x minus 4. And just like any other algebraic equation, you just treat the less than and equal to sign or greater than and equal to sign as an actual equal sign. So you're still moving the variables over to one side and keeping the numbers on another side. So for example, we got 5x, move the x over, so we get minus x greater than negative 4 plus 2. We got 4x is greater than negative 4 plus 2, which is negative 2. We divide both sides by 4, and we get x is greater than negative 1 over 2. So you're just essentially doing the same thing as if you were doing regular algebra. So just moving stuff to the left side and moving stuff to the right side. So a linear inequality is an inequality that contains an algebraic expression of degree 1. Okay? If it's higher than degree 1, then we're dealing with a polynomial inequality. If greater than 1, we have a polynomial inequality, which is the next lesson. And a double inequality, so a combination of two inequalities, so a valid solution must satisfy both inequalities. So that would just be minus 5, 2x minus 1 is greater than negative 5, and less than 7. So all you're doing here is you're just taking the 1, moving it over, so it becomes 7 plus 1, and we're taking the negative 1 and moving it over to the left side as well. So we get 1, so we get negative 5 plus 1, or 1 minus 5. So in order to solve an inequality, you have to find all the possible values of the variable that satisfy that inequality. So we're going to look at a chart right now, and we're going to figure out if the inequality is satisfied by these given x terms. So example 1, we want to do the following. X values satisfy the inequality 2x plus 5 is greater than 3. So we're not going to get into the algebraic part yet. We're just going to start by just subbing in random x values. So for this one, we want to sub in the value negative 2. So we're going to take negative 2, sub it in for x. So we get 2 times negative 2 plus 5 is greater than 3. When we simplify that, we get 1 is greater than 3. Is that true or false? It is false because 1 is not bigger than 3. Now we're going to do the other one. So we have x is equal to 1.5. So we get 2 times negative 1.5 plus 5 is greater than 3. When we simplify that, we get 2 is bigger than 3. And based off our basic knowledge of numbers, 2 is not bigger than 3. So this one is also false. And now we're going to get into x is equal to -1. So we sub in -1 for x. 2 times -1 plus 5 is greater than 3. When we simplify that, we get 3 is bigger than 3. Is that true or false? It is false because 3 is not greater than itself, okay? What would make 3 greater than 3 true? How could we make this inequality true? We would have to add the greater than or equal to symbol, okay? Which means 3 is equal to itself, but is also greater than itself, okay? And then the next one we have is -0.5 is greater than 3. When we simplify that, we get 4 is bigger than 3. And is that true? So again, 4 is bigger than 3. So this is true. And then the last one we have x is equal to 0. So we sub in 0 for x. 2 times 0 plus 5 is greater than 3. So we get 5 bigger than 3, which is always true. So as you can see, this is the tedious way of doing it without any algebra. Okay, so when communicating and describing in words, all the values would satisfy the inequality. Okay, so the inequality holds true for all x's greater than -1. Okay, and now what we're going to do is we're going to represent it on a number line, and we are going to use set notation. So here we have 0, we have 1 over here, and we have -1. When I'm identifying my -1, am I using my open circle or closed circle? Am I going to be using an open circle or closed circle on this number line for -1? We're going to use open because of this sign over here, okay? This means open circle all the time. If it doesn't have the equal to, it is always an open circle. We're going to do open circle, and because it's greater than -1, we are going to the right. And because we have to write it in set notation, we have x er such that x is greater than -1. Okay, and that would be our set notation. And for interval notation, how would it look like? So for interval notation, we have open bracket -1, comma, positive infinity, open bracket. Okay? So to show that a number is not included in the solution set, we're going to use an open dot at this value, and a solid dot, like I said, shows that the value is included in the solution set. Okay? Remember, if it's not included, use the open circle. If it is included, you use the closed circle. So now we're going to look at a chart. So can we add or subtract, multiply or divide both sides of an inequality by a non-zero value and still have a valid inequality? Okay. So we have 3 on one side and 6 on the other side. Give me a number that I should add both sides by. Give me a random number. Okay, we're going to use 2. So 3 plus 2, 6 plus 2, 5 is less than 8. Is that true? Five is less than 8, so it is true. Okay. Next one, we're going to subtract. Someone give me a value to subtract. So we're going to take 3, 3 minus 3, 6 minus 3. We get 0 less than 3. And as we all know, that is also true. Okay? How about the next one? We want to multiply by a positive number. Give me a positive number to multiply by. We're going to take 4. So we get 12 is less than 24. And that is also true. Now, how about if we multiply by a negative number? Someone give me a negative number to multiply by. So we're going to multiply by negative 2. So we get negative 6 is less than negative 12. Is that true? Is negative 6 less than negative 12? No. So this one is false. Okay? If we want to divide by a positive number, give me a positive number to divide by. Something that divides both of these into whole numbers. Don't give me a fraction. So we're dividing by 3. So we get 1 is less than 2. This is also true. And if we take into consideration what we did here, dividing by a negative number, is the inequality going to be true or false? So if we multiply by a negative number and it gave us a false, so it's also going to give us a false inequality. So divide by negative 3, divide by negative 3, you get negative 1 less than negative 2, and we all know that is false, okay? Because on a number line, negative 1 is on the right of negative 2. So we're not getting to the algebra part yet. We'll be getting into the second half of the lesson. So there are times where we do divide the variable by a negative number. So when this happens, when dividing or multiplying by a negative number, we must always reverse the inequality. Okay? So for example, let's just say we have negative 2x greater than 6. Divide both sides by negative 2. Now to keep this inequality true, we get x is less than negative 3. Okay? So now when you sub it back in, those x's less than negative 3 into the original equation, you will find out that negative 2x will always be bigger than 6 for x is less than negative 3. So how else are linear equations and linear inequalities different? Okay, so how many solutions does a linear equation usually have? So if we're just doing basic left side is equal to right side and sub in, we usually get one solution for linear equations. And based on the information I gave you guys about the definition of inequalities, how many solutions can linear inequalities have? So if we're given a double inequality, how many solutions do we have in that linear inequality? One or two? So with linear inequalities, we can have many solutions. Okay, so with anything that involves solving for the left side and the right side, in order to verify your solution to an inequality is correct, we need to do left side is equal to right side. So for example, let's just take what I put above. So we did negative 2x greater than 6, divide both sides by negative 2. We have to reverse the inequality, so we get x is less than negative 3. So now to verify this, I need to take x is less than negative 3 and apply it to negative 2x greater than 6. So this is our left side. This is our right side. So what's a number less than negative 3? So we're going to sub in negative 4. So this is equal to 8 is greater than 6, and this is true. Okay? So as you can see, reversing the inequality when we divide by a negative number helps to keep the original inequality true. Okay? So remember, when you're dividing the variable by a negative number to isolate for it, you are reversing the inequality. So you're flipping the sign. So we're going to have an example right now. So we have 2x plus 5 is greater than 3. So looking at it graphically, at what point, at what x value is the equation 2x plus 5 bigger than 3?
You're the oldest. I used to have that phone.
Less than a lifetime, man.
Yeah, that's right. I just have to get to this. Yeah, I still have mine, but it's a bunch of things that like mechanical issues.
That's true.
So, yeah.
Right. So at x is equal to negative 1 is where this graph is bigger than positive 3. So as you can see from here, the graph is bigger than 3. Okay, so now we want to solve it algebraically. By the way, if you didn't know who that was Mr. Bizzelli coming in to grab some of his stuff. Okay, so 2x plus 5 is greater than 3. We want to leave the 2x on the left side, so we're going to move the 5 over. So we get 2x is greater than 3 minus 5. 2x is greater than negative 2. Divide both sides by 2. X is greater than negative 1. Okay? And as you can see, based off the graph, that holds true. Now, in order to verify this even further, let's just do left side and make sure it obeys what the right side has. So our left side, we have 2x plus 5. And our right side, we have 3. So someone give me a number bigger than negative 1. So let's take 2. So 2 times 2 plus 5, this has to be bigger than 3. So you get 4 plus 5 is bigger than 3. We get 9 is bigger than 3. So we know this holds true for all x's bigger than -1. Any questions so far? Or are you guys getting this pretty easily? Okay, see, advanced functions isn't that hard. Even with trig, it shouldn't get that much harder. I'll just try my best to explain it in the best way possible so that you guys can understand it at a high level. Okay, so basically inequalities, you're using what we did from the last unit with polynomial functions and what you know from linear equations, and you're just applying basically the equal signs just change to greater than or equal to or less than or equal to. That's all that's really changing when it comes to advanced functions and those concepts you learned from grade 10 and 11. All right, so we have the next examples. So we want to solve each of the following inequalities, and we want to state the solution in both sets and interval notation. And then we want to graph it on our number line. Okay. So the first one we have is 4 times 3x minus 5 is greater than or equal to 6x. So what is our first step going to be in order to solve this inequality? What is the first thing we're going to do? So we're going to expand. We're going to FOIL in the 4x into the bracket. So we get 12x minus 20 is greater than or equal to 6. We want to move the variables over to one side and the constants to the other side. So we're going to bring the 6x to the left side and move the -20 to the right side. So we get 12x minus 6x is greater than or equal to 20. 12x minus 6x gives us 6x is greater than or equal to 20. Divide both sides by 6. And in simplest form, what is our fraction? (10/3). So now we have to express this answer of x is greater than or equal to 10/3 in set notation and in interval notation. So in set notation, it is going to be XER such that x is greater than or equal to 10/3. And in interval notation, how would it look like? Am I going to have a square bracket or round bracket at 10/3? So we're going to have square bracket 10/3 to infinity. And Yusuf answered the next question. We are going to have a closed dot at 10/3. So this is 10/3, and it's anything bigger than or equal to 10/3. So anything to the right of 10/3 is going to make the statement true. All right, so we're going to move to example 2b. So we have 3x plus 5 is less than 10x minus 2 times 2x minus 1. So what would be our first step to solving this inequality? So the first step is to expand. We're going to multiply the negative 2 into our bracket on the right side. So we have 3x plus 5 is less than 10x minus 4x plus 2. Okay? So we can collect our like terms on the right side. So it just becomes 3x plus 5 is less than 6x plus 2. Okay? So let's just move all the variables over to the left side and the constants to the right side, because I want you guys to have an example of dividing by a negative number. So we're going to get 3x minus 6x is less than 2 minus 5. So 3x minus 6x gives us negative 3x is less than negative 3. Now, if we divide both sides by negative 3, what happens to our inequality sign? It flips, okay? So we get x is greater than 1. Now, I want you guys to do this alone. What would have happened if I moved all the variables, all the x's to the right side and all the constants to the left side? What answer would you get still? Someone tell me if you get the same answer as we got in this example. Right, so even if we wanted to avoid that whole negative number thing, if we moved all the variables over to the right side and all the constants to the left side, we still would have gotten x's greater than 1. Okay, so now we're going to write this in set notation and in interval notation. So we have set notation, we have XER such that x is greater than 1. And then what would our interval notation look like? Open bracket or close bracket? I mean, open bracket or square bracket, sorry. Open bracket 1, comma, infinity, open bracket. And for our number line, open dot or close dot. So we're going to have open dot 1, and it's everything to the right of 1 that makes this inequality true. So now we need to check if our work is actually right. Okay, so this is where the checking if the left side satisfies the right side comes into play. So we're going to verify the solution in example 2a using a left side and right side check. Okay, so our solution to 2a was x is bigger than or equal to 10 over 3. So we know our left side is 4x, 4 times 3x minus 5, greater than or equal to, and then our right side was 6x. So someone give me a whole number that is bigger than 10 over 3. So let's take 4, okay? 2 is less than 10 over 3 because 10 over 3 is 3.333. So we're going to sub in 4 for x. So we get 4 times 3 times 4 minus 5. And then on the right side, we get 6 times 4. The right side simplifies to 24. And what does the left side simplify to? 28. So we get 28 is greater than or equal to 24, and that is true because on the number line, 28 is to the right of 24, which makes it bigger than 24. Okay? So this is how you would check your answer. Our next example is going to involve a double inequality. So we have two conditions to follow. So our double inequality for the next one. So we want to solve the double inequality. 11 is less than 3x minus 1, which is less than or equal to 23. And we want to express the answer in interval notation. And then we want to graph the solution on a number line. And we want to verify it graphically on the following sheet. So let's just write down our double inequality again. So we have 11 less than 3x minus 1, which is less than or equal to 23. So to leave 3x by itself, what do we have to do with that negative 1? I showed you guys what to do on the first page of the lesson. What we do when there's a double inequality. We're going to distribute it to both sides. So the negative 1 is going to come over to the right side, but it's also going to go over to the left side. Okay? So we got 11 plus 1 is less than 3x, which is less than or equal to 23 plus 1. So we got 12 less than 3x greater than or equal to 24. And now to just solve this inequality, we're going to divide both sides by 3 to get x by itself. These cancel out. 12 divided by 3 gives us 4, less than x, less than or equal to 8. All right? So for our set notation, it would be XER such that x is greater than 4, but less than or equal to 8. And how would it look like as interval notation, guys? How would we write this inequality in interval notation? So open 4 and closed 8. That is correct. All right, and last but not least, we're going to have to draw it on a number line. So we have 4 and 8. Is 4 going to have an open dot or closed dot? So open, and then is 8 going to have an open or closed? It's going to have closed. So the area we are looking at is between 4 and 8, but the number 4 is not included. All right? So what we're going to do right now is we're going to check if the inequality is true. Okay? So here we have left side, right side, and literally the middle. So what we're going to do is give me a number between 4 and 8 that doesn't include the number 4. No, I'm just doing this just to get you, just in case I ask you guys to check. So we're going to sub in 6. So we have 11 less than 3 times 6 minus 1 greater than or equal to 23. So we have 11 is less than, what's 18 minus 1? So 17, which is greater than or equal to 23. So our main focus when we're checking is always the number that involved the inequality expression, okay? So the number that involved 3x minus 1 was 17. Is 17 bigger than 11? Yes or no? So this is correct. And is 17 less than or equal to 23? And that answer should also be yes, which means our interval in our solution is correct. So x has to be between 4 and 8. And then last but not least, we're going to check it graphically. Oh, did you guys hear there's supposed to be like a lot of snow for tomorrow? Yeah, apparently there's supposed to be a good chunk of snow falling overnight. So let's just look at our graph now and just that this is our last example. So now we want to verify that the inequality 3x minus 1 is less than or equal to 23, but greater than 11, okay? So let's look at so we had, I believe, in interval notation, we had 4, comma, 8. So this is the intervals we are looking at. So as you can see, when x is 4, so here's our open dots, okay? It is bigger than 11, which is true because this is 11 and it keeps getting bigger. But when x is equal to 8, the values are less than or equal to 23. Okay, so when it comes to, let's just say a question on a test or an assignment, not necessarily a multiple choice test because it wouldn't be possible. I might ask you to graph out an inequality based off the solutions or based off the interval and set notation and giving you the function of it, okay? So that might be a question. Remember, tomorrow you have your assignments, which are communication, thinking, and application, part of Unit 2. So cohort A, you guys are lucky. You guys get to ask me questions tomorrow about the assignment if you want to. I will post it at the beginning of class, and you guys have up until 11:59 that night to hand it in. I believe it's 6 to 8 questions, and the total I believe is around 30 to 32 marks. So obviously it's more significant than your quizzes. This is going to be worth 3% of your mark. Okay. How long should it actually take? No more than an hour. Basically, if you were to write it in person in regular school, it should take you should have more than enough time to check your answers before the period ends. So I would suggest not leaving it last minute and just doing it as soon as possible. But yeah, it's not the hardest thing in the world. Just hopefully all of you paid attention to what I said about the absolute max and local mins on Friday when I gave a little lesson about that. Okay. So we are, you guys are, we are learning a lesson tomorrow. That is what we are going to do. So tomorrow I'm going to give you guys a lesson, and then I'm going to give you guys a chance to work on the chapter review and mid-chapter review for Unit 3. And then we're going to move on to Unit 4 by Wednesday. Okay? So hopefully that's good with everybody. Hopefully there's no complaints. I haven't heard any complaints yet. So that's probably about it. So you guys can go on and work on the homework. for 4.2. And then, like I said, on the days we're doing this online class, I know I forgot to say it today, but always assume I'm available to answer your questions from 12:10 up until the beginning of class. I had one person come today. I usually have one or two students every time we have the online class. So if you ever have any questions, feel free to drop by between 12:10 and 1:05 to get your homework questions answered.